Okay. Hi guys. Sorry I can't be there today, but I wanted to post at least a little short video here to kind of talk through the notes. So I've already filled the notes out for you, and they're in OneNote so you can see them. I don't think I need to talk through every little thing here, but I want to at least go over some of the things that you are going to see. So a couple things as well. When I get back tomorrow, we'll talk about the Unit 10 test and some opportunities you have to earn back some points on that test. And I'll also talk about the final review. Know for now that the final reviews are available. If you go over to the review for final 2 or final review of 2, there's a paper review. I would not recommend this one completely. There's a lot of good multiple choice here that might be useful, but a lot of the problems here are probably quite a bit harder than what you're going to see on the final. But feel free to use this as much as you want. All of the answers are at the end. Where I would say I direct you to do some more practice is I've made a big giant Delta Math final review, and that's got lots and lots of questions to help you go through and some kind of that way you can show example and see how to do it. So I'll talk more about that tomorrow, but just know that those things are there if you want to start working on them. Okay, we've got one more unit to do before the end of the year. It's fairly short, it's pretty straightforward. Basically, it's just kind of experiencing some formulas. We will give you the formulas on this last test. You just have to kind of know the right parts to plug in to then find volume and surface area of some 3D shapes. Okay, so to start here, just really quickly, up at the top here, we've got 5 different 3-dimensional shapes: prism, pyramid, cylinders, cones, and spheres. You want to be able to identify which is which. The thing about these two, so prism and cylinder, they're kind of similar in that they always have 2 bases. So if I look at a prism, I've got this kind of top part triangle and this bottom triangle. Those are the bases. And in a cylinder, those bases are circles. So in a prism or a cylinder, your bases are the 2 pieces that are always the exact same shape. The other ones, a pyramid and a cone, are similar. They each have 1 base. So this one's got a triangle, this one's got a circle, and then they meet kind of at this point, or vertex is what it's called, up at the top, right? So they each have that cone. So instead of having 2 bases, they have 1 base and they meet at a vertex. And then we have a sphere, which is obviously a 3-dimensional circle, basically. Okay, so when we're naming shapes, you got some different names here of things. Cone, cylinder, those are just their name. Sphere, the ones that get an extra word are when we talk about prisms and pyramids, and we name those by the shape of their base. So for example, in number 1, that's a pyramid. The shape of the base is a rectangle, so that's a rectangular pyramid. Okay. Over here on number 3, that's a prism because it's got 2 bases, but the bases are triangular, so it's a triangular prism. This one here is a little bit different. We've got a hexagon, and then they're meeting at a point, so it's a hexagonal pyramid. Over here, number 9, our 2 bases on this prism are pentagon, so that's a pentagonal prism, and so on. You can kind of see it in the other ones. One of the ones that people tend to struggle with a bit here, and I know it's hard to see, is number 7. That is a trapezoidal prism. So even though they all have 4 sides, the bases there are those trapezoids because they're not the rectangles that are the other pieces. Okay. With prisms, just know that your 2 bases will always be the exact same shape. So that's kind of how you can figure out where your bases are. And we'll kind of look at that a little bit here in a few. Okay, so those are our shapes. Now we want to talk about surface area, and then we're going to also see volume of prisms and cylinders is where we're going to start. Next time we'll do pyramids and cones. So on a prism, we've got a couple types. So these first 3 problems here are rectangular prisms or cubes. When we talk about those, to find our surface area, which remember surface area is like if you were going to wrap a box in wrapping paper, the amount of wrapping paper is your surface area. It's the area of all of the surfaces of that prism. So basically I'm finding in my picture here, that first one, I've got a blue, a purple, and a yellow rectangle. I'm going to find the area of each of those, but then there are 2 of each of that rectangle. So I'm going to multiply each one by 2, right? So we've got the 2 times 13 times 17, 2 times 9 times 13, and 2 times 7 times 9. So 2 of each of those rectangles, and then add them all up, and we get our total area of 542. And it's the same thing for number 2 and number 3. So if you don't want to write all 3 of those down, that's fine, but make sure you get at least one example. That's kind of our first formula over here for a rectangular prism only. Now, in a rectangular prism, all of the faces are rectangles. So it doesn't really matter which ones I pick as my base, but I'm always going to pick 2 of the same rectangle. Okay. Okay, now if it's not a rectangular prism, then that means we've got a prism where the bases are different shapes. So triangles or trapezoids or hexagons or rhombuses or whatever. So in this case, say in our number 4 here, we've got a prism, and the 2 shapes that are not rectangles are these bases here, right? And they are triangles. So that is a triangular prism. Okay. Okay, now to find the surface area of that, well, we need the area of the 2 bases. So this is our first part here, right? This SA stands for surface area. The first thing we need to find is the area of the base. So this big B down here, that's the area of the base. And then we need 2 of those, so I'm going to multiply it by 2. Then I need the area of all the space that kind of connects those 2 bases, right? And if you open that up to lay flat, it will actually be a rectangle. And the area of that rectangle is the height of the prism times the perimeter of the prism, right? The height of the prism, and then the distance around here, if I get that bottom part, that's the perimeter of the base, which is also the base of our rectangle if I were to open that up. So that's how I'm going to find the surface area of a triangular prism. So this first one, you can kind of see me go through here. I'm looking at one of my triangles. So I'm going to look at that one on the bottom. I know that the hypotenuse here is 15. And then using this 9 here, I can bring it down to get that leg. I don't know the other leg over here, and I need that to find the area of the base, or the area of that triangle. So over here is where I'm finding the area of the base. Since it's a triangle, it's 1/2 base times height. And to find that height over there, I'm going to use my Pythagorean theorem. Since I know the 9 and the 15, I can plug those in and solve for x, and I get 12 for the other leg there. Okay, so that was just found using Pythagorean theorem. Then I can do 1/2 9 times 12, which is what I'm doing there, and we get a base area of 54. Okay. Then to find the lateral area, I'm going to do the height of the prism times the perimeter of the base. Well, perimeter of the base, I'm just going to add up 9, 12, and 15. That's how I get that 36. And then the height of the prism, and this is one that people tend to have trouble with for a minute, the height of the prism is the distance between the 2 bases. So if I'm looking at my 2 triangles here, the distance between those would be this height. So 16 is the height of the prism. Okay, so that's where I get that 16 from. And if I can calculate all of that, I get 576. So then to find my total surface area, I take the lateral area plus 2 times the base area, and I get a total of 684. Okay. The other 2 are very similar. I'm going to find the area of the base, and then I'm going to find the lateral area, add those together to get total surface area. This other one's on another triangle here. Number 6 here is a trapezoid. So you'll notice that over here, when I find the area of the base, I'm using my area of a trapezoid formula. You might get to some where you have to do a little more work to find it. Again, on this one, I'm going to have to do Pythagorean theorem to get that side of the triangle. On this trapezoid, I've got my height drawn in here, right? But I don't know that. So I'm going to have to kind of use the fact that I know that's 10. Then the whole thing is 18. So I know that this is 4 and this is 4. I know this is 13. So again, I can use Pythagorean theorem there to get my height of my trapezoid to solve for that. Okay, we might have some 30, 60, 90 stuff in here. So all those things that we learned in Unit 11 about finding area of shapes, we're now going to use that to find the area of the bases of our prisms and pyramids and such. Okay, then a cylinder is basically just like a prism. The only difference is that our bases are circles. So your formulas over here are going to look very similar, right? It's 2 times the area of the base. That's what this part is here. It's just that the area of the base is a circle, so it's pi r squared. And then same thing, I'm going to do the height of the prism times the perimeter of the base. But since the base is a circle, the perimeter is the circumference of that circle. So that's where that 2 pi r comes from. So doing the same thing, I can find the area of my base and my lateral area, and then add those together to get the surface area of the cylinder. Okay, very similar to the way we do prisms. A couple application problems here where you're given surface area and you have to find some other variable. Again, I'm just using that formula, plugging in the things I know to then solve for what I don't know. And same thing on number 12. Okay, then moving on to volume of prisms and cylinders. Volume we find is a 3-dimensional measurement. That's the amount of stuff that a prism or a cylinder can hold. So how much cereal can a cereal box hold? How much soup can a soup can hold, right? So on this one, for a rectangular prism, it's pretty simple. You guys have probably learned this one before. It's just length times width times height if it's a rectangular prism. So I take here my 9 times 17 times 24 to get the volume. If it's a different shape prism, so triangular, trapezoidal, whatever, we're going to kind of do the same thing, but now we're going to find the area of the base, and then we're going to multiply that times the height of the prism. So kind of similar to surface area, but actually a little bit shorter. So this time I still got to find the area of my base, but then I'm just going to multiply by the height of the prism. So we've got a couple different ones here. This first one, I've got a triangular, oops, do that with the highlighter, a triangular prism. So I've got a base that is a triangle shape here, right? And in the dotted version of that, it's showing us there that the height of this triangle here is 7.3, right? So if I use that as my height, then I'm going to use the 12 as the base. So to find the area of my base, I'm going to do area of a triangle, 1/2 base times height. So 1/2 12 times 7.3. And then remember, to get the height of your prism, you want the distance between the two bases. So if I'm going from triangle to triangle, then the height of my prism is 5. So that's where I get this. So then to find our volume, I do area of the base times the height, and we get 219 feet cubed because it's the volume. Okay, same thing on all of our other prisms. Find the area of the base, multiply by the height. Notice on this one, we've got our 60-degree angle there, so that's a 30, 60, 90. We can use that to find the height of our triangle, and then we can use that to get the area. Trapezoid, you've got your height, right, and your two bases, but same idea. There's a couple other here. This one's got kind of a different shape in number 8, and I kind of showed you how I found the height over there. But again, going through the same idea, right? Pythagorean theorem or 30, 60, 90 can still come in handy, but find your area of your base and then times the height. Cylinders are exactly the same way. It's just, again, your area of your base is a circle. So instead of writing area of the base, we just put pi r squared. So we're doing pi r squared times the height. We'll look at number 10 this time. Notice 11 here is your diameter of the circle. So I want to take half of that to get my radius. So that's where I got that 11/2. So I got my pi r squared times the height of the prism, which is 21, or sorry, of the cylinder, which is 21. And then I left my answer in terms of pi there. If you gave it as a decimal, that's fine as well. Just make sure you use the pi button, not just 3.14. And then again, we've got some different application problems here, applying those things to kind of different problems. If you want to see how those work, they're there. Okay, so very quick little talk through of the stuff on these. Your formulas are off to the side there. Try some of the homework, see how it goes. We'll go over some questions when I'm back on Friday. On the homework, though, one last thing. Get this to work. We decided in the other two classes that the homework, which is a worksheet, we are going to do the odds only. So you don't have to do every single problem. Of course, you are more than welcome to do so, but we're going to do odds only for these. Okay. All the answers are posted. So if you want to do all the problems and check, or if you want to skip around and do some extras, that's fine. But I'm only going to grade and require the odds. All right. I will see you guys on Friday. Have a good one.